Okay. So, last time I told you I wanted you to take a look at the review and see if there was anything that was giving you any problems. So, before I get into this review, is there anything in particular we would like to go over? Anything? Okay. So I've got a copy of the review here. It's all the same type of questions, but different numbers on those questions. So first, determine whether the statement describes a population or a sample. The high school GPAs of all the employees at a textbook company. So which is that? Yeah, population. What's the key word here that tells us that it's a population? All, yeah. So if it was just describing a part, it would be a sample, but since we have all of the employees, and this is a population, good. Number 2, in an experiment, neither the subject nor those conducting the experiment know whether the subject is in the control group or the treatment group. Is that a single blind or double blind study? Double blind, yeah. In a double blind experiment, nobody knows who's in what group, whether they be in the control group or the treatment group. All right, next one. Determine whether an observational or experimental study is appropriate to address the following statement. A general manager of a restaurant wants to find out her average daily receipts. So is that observational or experimental? So do we need to change anything in our environment to get our data here? Or do we just need to collect the data? So once again, she wants to find out the average receipt value. So is she going to need to change anything about how those receipts are collected? Is she going to need to change anything about the values on the receipts? No. This would be purely observational. All she has to do is collect those receipts and get an average. Experimental would be she has to change something. Remember that in an experiment, we are changing an experimental variable. Okay? A physics instructor wants to determine if taking a calculus course before taking his physics course improves students' grades in the physics course. The average class grade would be considered the what? Explanatory or response variable? That would be response variable. Very good. So explanatory variable is one of those things that we have that has the possibility to explain the phenomena that is occurring. However, a response variable is what? Yeah. Yeah, so what the response is here is that they are being affected by the, the calculus course. Okay? So it's responding to that effect. Any questions? All right. This one's kind of cut off here. A mid-size mobile carrier keeps records of complaints received from its customers. Complaints for last month are listed in the following table. What percent of the complaints are due to the category incorrect billing? Round your answer to 2 decimal places if necessary. Okay. So again, what we want to know is, of all of these, what percent is just this one, incorrect billing? Okay. So remember that percents have to do with a proportion. So a percent is always out of 100. And so this incorrect billing is out of a total. Okay? So we know that the value of incorrect billing is 89. So there's 89 in that frequency. Now we need to know what the total is of all of the customer complaints. So we're going to need to add up all these numbers. So we have 118 plus 99 plus 87 plus 92 plus 106 plus 89 plus 43 plus 156. And we have 790. That was fast. Okay. So let's see if it is. So if we want to find the percent, we need to equate this part out of the total to a percent over 100. Now that we have it equated, what we can do is we can multiply the numbers that are across from each other, so 89 times 100, and that'll give us 8,900. Okay, and then we divide by the number that's left over, so we need to divide this by 790. So 8,900 divided by 790 is about 11%, and it wants us to round it 2 decimal places. So this is going to round to 11.27%. Big thing though is just to get this thing set up correctly. So again, it's part out of a whole. So this is the part, the total is the whole, is always equal to a percent out of 100. And then you just multiply the numbers across from each other and divide by the one left over.
Wait, do you have to multiply it across? I just did 89 divided by 790.
Yeah, you can do 89 divided by 790, and then you need to convert that into, from a decimal, because this will be a decimal, convert it to a percent.
Okay.
So that's what the 100 does for us.
Okay.
So yeah, you can do 89 divided by 790 and then just convert to a decimal using that 100. Any questions? All right. Number 6, consider the following data. So we've got a set of data here, and it wants us to give the mean, the median, and the mode if we have a mode. Okay. So let's see. The first thing we ought to do is put this in order from least to greatest. And so we've got, let's see, negative 14, negative 3, then 0, 3, 12, and 14. Okay. So again, we want to find the mean, the median, and the mode. So let's find that mean. So it's just the average, so add all these up, divide by how many we have. So how many data points do we have? 6 data points, good. So we have 0 plus 3 plus 12 plus 14, then minus 14, and minus 3. So that gives us 12, which makes sense. It's the only one that's not getting canceled out. And then divide by 6. And we, of course, get 2. So we have a mean of 2. Okay. Next, determine the median of the given data. Okay, so the median is the number directly between 0 and 3 in this case, since these are both in the middle. So what is directly between 0 and 3? Well, we can take 0 plus 3 and divide by 2, and that'll give it to us easily. Is what, 1.5? Yeah, good. Okay. And then finally the mode. So the mode is the number that occurs the most. Well, do any of these numbers occur more than once? No. So this one doesn't have a mode. There is no mode. Any questions so far? All right, let's keep going. Oh, next one's at the bottom of this page. Calculate the GPA of a student with the following grades. So they have an A for a 17-hour course, a B for an 11-hour course, a C for another 11-hour course. And then it gives us the grade breakouts. Well, that's not easy to see, is it? Okay. So GPA, weighted mean, we've got to multiply these hours by the values of these grades. Okay? So A is a 4.0, so 4 times 17 is going to give us 68. Then B is a 3.0, so 3 times 11 is 33. C is a 2.0, so 2 times 11 is 22. Okay, and this is out of the available hours, so 17 plus 11 plus 11. So that will give us 39. Okay, so let's see what we have on top. 68 plus 33 plus 22 gives us 123. Now we just need to divide that by 39. And we get, let's see, round your edges to 2 decimal places, so this will be 3.15. Any questions? Nope. All right. Next, for the graph shown, determine which letter represents the mean, the median, and the mode. Letters may be used more than once. Okay, so we've seen this one before. First of all, the mode is the number that occurs the most. And so on this graph, a hump, so as this thing increases, these numbers are increasing in frequency. Okay? So this hump right here shows us the most frequent number, which is the mode. So that'd be A. Okay? Then the middle number, B, is the median. And then that just leaves us with the mean, C, which is on the other side of the median from the mode. And there we go. Any questions? All right. Next, number 9. Oh, I think I took variance off for y'all, but we can do that one as well. So consider the following data. It gives us some data points. Find the sample variance, the sample standard deviation, and calculate the range. Okay. So sample standard deviation, okay, is different from population standard deviation. So let's see, I'm going to put that up here, and that is the standard deviation for a sample is S equals the square root of the sum of x minus x bar squared over n minus 1. Okay, and it's that n minus 1 that is different for a sample. If this was a population, it'd just be n. Okay, so the first thing we need to determine is our mean, our x bar. So we need to get the mean of all these numbers. Let's see. -6 plus -4 plus -9 plus -4 plus -4 plus -9, and then divide by, let's see, 6 gives us -6 for our mean, our x bar. Okay. So now, variance. Variance, again, I'm pretty sure I took this part of the question off because I'm not really concerned with y'all getting variance. But variance is everything besides the square root. So once you work out all of this underneath the square root, that's your variance. Then once you take the square root of it, that's your standard deviation. Okay, that's why I'm not that concerned with y'all knowing variance, but we'll do it. Okay, so we need to take each of these numbers and subtract the mean from it. All right, so -6 minus -6. Well, if you think about that, -6 minus -6, like that. This becomes -6 plus 6 because of this double negative. So that's 0. Okay? And so all of these are going to be plus 6 instead of -6 because of that double negative. So -4 plus 6 is 2. Negative 9 plus 6 is 3. Be negative 3. Negative 4, we have another 2. 2. Negative 9, we have another negative 3. Okay, so there's all of our x minus x bar numbers. Now we need to square all of these. So 0 squared is 0, 2 squared is 4, 3 squared is 9, 2 squared again is 4, and 9. So there's all of our x minus x bar squared numbers. Now we just need to sum them. So 0 plus 4 plus 9 plus 4 plus 4 plus 9. Oops. Let's see. 4 plus 9 plus 4 plus 4 plus 9 gets us 51. And now we need to divide that by n minus 1. So what is our n? Let's see. 6. So n minus 1 is 5. So divide 51 by 5, and we get 10.2. So that's our variance. Again, the variance is just everything before the square root. Once you take that square root, you have standard deviation. All right, so let's go ahead and get standard deviation. Take the square root of that number. And we get, I just said one decimal place, so 3.2. Again, it's just the square root of the variance. All right, and calculate range. So our range, highest number is negative 9. Minus the lowest number, okay, so this turns into plus 4. Alright, so negative 9 plus 4 gives us negative 5. Any questions? It doesn't need to be negative, sorry. It's a range. Range is a distance, so it doesn't need the negative on there. It just needs the number. No questions? All right. Next one, number 10. Suppose that a company wishes to predict sales volume based on the amount of advertising expenditures. The sales manager thinks that the sales volume and the advertising expenditures are modeled according to the following linear equation. Both sales volume and advertising expenditures are in thousands of dollars. Okay, so here's our model that this guy's come up with. It's estimated sales volume equals 47.58 plus 0.55 times advertising expenditures. Okay? And again, they said that both of these are in thousands of dollars. So if the company has a target sales volume of $300,000, how much should the sales manager allocate for advertising in the budget? Okay, round your answer to the nearest dollar. All right. So again, what we want to know is if we want to make $300,000, so estimated sales volume, 300,000, how much should we spend on advertising? So what we're going to do is we're going to plug in 300,000 into here. Now remember, this said Both of these are in thousands of dollars, so I need to plug in 300 here, not 300,000, because this is already in thousands. Okay, so 300 equals 47.58 plus 0.55 times advertising expenditures. That's what we're trying to figure out. I'm just going to call it A, because I don't want to have to write that over and over and over. And now we need to solve. So the easiest part to get rid of first on this side is 47.58. We can subtract it from this side. And of course, if we do something to this side, we have to do the same thing to this side. So minus 47.58. So this side it cancels. Then we need to figure out, let's see, 300 minus 47.58. That gives us 252.42. Okay. And now we need to get rid of the 0.55 from A. So right now it's multiplying by A. We need to divide. So that should cancel there. Let's see. Times 0.55. Let me recalculate this real quick. I'm getting a weird answer. What the hell? I'm getting a strange answer for this one. It's not coming out right. Yeah. Well, no, 458 is what it's supposed to come out to be. But every time I enter it in the calculator, I'm getting 554. What are you doing?
Are you multiplying it or are you dividing it?
Dividing it. And you did 300 minus 47.58, right? And then divide by 0.55. Oh, it worked that time. I don't know why.
It's working.
I guess I entered something wrong on the calculator. Yeah. Weird. So we get an answer of 458.9454545, so on and so forth like that. Remember, we need to put this into thousands though, since this original one is supposed to be in thousands. Okay. So we need to give this 3 more spaces. So move it 1, 2, 3. So this will be 458,945. Any questions? None? All right. So that's what you can expect course, out of the review, but also the test. The test is going to be quite similar to the review. So how do we feel about that review? Think we could do it? All right, good. Remember, we have our test on Friday, okay? And the review is also due Friday. So I would like for everybody to get their review in Friday before class, but it's fine if you don't. Just get it to me Friday before midnight, okay? But I want you to get it in before class so that you have done the review before you get to the test, okay? All right, but that'll do it for today. Be sure to work on that review, and I will see you on Friday.